Hello students, welcome back to video lecture series for the subject Mathematics 3. Myself Dr. Ankit Acharya, and today we will discuss about our second chapter, numerical integration. Okay, so in this chapter we solve some example using numerical integration, because we know that every time integration is not so easy, or sometimes integration it's not possible to find for every function. So for that we are using numerical integration, okay, to find out the approximate value of that function using integration. Okay, so here is an introduction. You can see that the process of evaluating a definite integral from a set of tabulated values of f of x. So in this case, the values of x and the values of f of x either given or you can find using your function, okay, is called numerical integration. This process, when applied to a function of a single variable, is known as quadrature. In numerical integration, f of x is represented by an interpolation formula, and then it is integrated, okay, between the given limits. Okay, finite integration limits is always given. In this way, the quadrature formula is derived for an approximate integration of a function defined by a set of numerical values only. Okay, so there are three methods in your syllabus. First one is a trapezoidal rule, then Simpson's 1/3 rule, and then Simpson's 3/8 rule. Okay, so using this three formula, you can find numerical integration. So let's start with first formula, trapezoidal rule. Okay, so this is your trapezoidal rule to find numerical integration. This is your first method, very important. Formula, try to understand the formula. Integration from x0 to x0 plus nh, okay, f of x dx, that is equal to h by 2 y0 plus yn. Now what is y0 and yn? Y0 is the first value of the table of y, and yn is the last value. Okay, so first value and last value, don't forget, this is the first value of the y table, and this is the last value. Clear? And all other values, okay, between y0 and yn here, y1 plus 2 into y1 plus y2 up to yn minus 1. Okay, let me give you one example. Suppose your integration from 1 to 6, function is f of x dx, okay, and suppose your h is equal to let's say 0.5, right? Okay, so what is the value of x? X is 1, we are starting with 1. F of x is x square. Suppose let's say f of x is x square. Okay, so 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, okay, 5, 5.5, and 6. And corresponding to this x, you will get f of x, because f of x is what? X square. So 1 square 1, then 1.5 whole square, whatever the value, 2 square 4, okay, 2.5 whole square, 3 square 9. So you will get all these values of y, and in this formula, okay, in this formula you have to take y0 plus yn. So y0 is what? First value, y is equal to f of x. So this is your first value, and yn means what? The square root of the square of 6, that is 36. Okay, so in this formula you have y0 plus yn, so that is 1 plus 36. Clear? Okay, and h is 0.5 by 2 plus 2 into all in between these two values, 1 and 36. So 1.5 whole square, whatever the value, 2 whole square, and so on. Okay, clear? Easy to understand. So let's try to solve one or two example. So here is the first example. Use trapezoidal rule. Okay, they already mentioned the name of the method. Use trapezoidal rule to evaluate integration 0 to 2. Integration from 0 to 2 x. This is your function x, square root of 2 plus x square. Okay, this is my f of x here, dx. So what is my f of x? F of x, that is x upon square root of 2 plus x square, right? X0 is what? X0 is 0. Okay, the first value of x, x0 is 0, lower limit. X0 means lower limit, and this is your final value. Okay, so x0 is 0. Now dividing the interval 4 equal part. 4 equal part means uh, if you want to find h is what? Xn minus x0 upon n. Okay, what is xn? Xn is the upper limit, x0 is the lower limit. So 2 minus 0 by 4, because we want to convert in 4 equal parts. So that's why 2 by 4. So 1 by 2. Okay, and 1 by 2 is what? 0.5. So that's why your h is equal to 0.5. Clear? So h is now fixed 0.5. So that's why here you can see that the values of x, that is 0, starting with 0, 0.5, 1, 1.5 and up to 2. Okay. Now corresponding to all this x, you can easily find out the value of f of x using your calculator. 0, put 0 in this function. So you will get 0, 0.5. Okay. This all the values you have to calculate using your calci. Okay. Using your calculator. So 0.5 divided by 2 plus, suppose you want to find, just a minute, I will show you. Suppose you want to find this value. So you have to calculate this value, f of 0.5. That means 0.5 divided by square root of 2 plus 0.5 whole square. So when you calculate this value using your calci, you will get 0.3333. Okay, this value. Clear? Similarly, when you find out f of 1, f of 1 is quite easy. Okay, 1 upon square root of 2 plus 1. So 1 by root 3. Okay, so 1 by root 3. So you will get 0.5774. Clear? Okay. So corresponding to 1.5, you will get this value. 2, you will get this value. Now what is my trapezoidal rule? H by 2. See, this is my trapezoidal rule. Okay. H by 2, y0 plus yn. So suppose I want to apply trapezoidal rule here, then y equal to f of x. Okay. So integration from 0 to 2 x upon square root of 2 plus x square dx, that is equal to h by 2. H by 2 means 0.5 by 2 y0 plus yn. So y0 is first value, yn is the last value. So 0 plus 0.8165 plus 2 into all this 3 value, okay, in between. So 0.3333 plus 0.5774 plus 0.7276 and plus 0.8165. Okay, so you can easily calculate this value using your calculator. Okay, and that will be see, h by 2, 0.5 by 2, 0 plus 0.8165 plus 2 into all other in between values. So that is 1.0233. This is your final answer. Okay, and this is approximate value of the function using integration. Right? Let's take one more example. This is important example. Evaluate integration from 0 to 1 e raised to x. Okay, e raised to x dx when n equal to 10. Okay, using trapezoidal rule. Now n equal to 10. So first of all, we find the value of h. Sometimes what happens, the value of h is given. Okay, in some of the examples. So you can directly take that value. Sometimes they inform that you have to take n equal to 5, n equal to 10, n equal to 6 in equal part. Okay, so using n, you can easily find out the h. H is what? Okay, sometimes they use this formula xn minus x0 upon n, or sometimes they use this formula b minus a upon n. In both the case, the meaning is same. Xn is the upper limit, x0 is the lower limit. Here also b is upper limit, a is lower limit. Okay, so don't be confused at that time. So xn upper limit is what? 1. This is your upper limit. This is your lower limit. So 1 minus 0. And how many parts you have to take? 10 parts. Okay, with n equal to 10. So 1 by 10. So 0.1. So h is equal to 0.1. So f of x is e raised to x. Okay, f of x is e raised to x. So you can easily calculate 0. Right? Now concentrate on this. X is 0. Then 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7 because h is 0.1. So 0.8, 0.9 up to 1. Sorry, this is not 1.1. So mistake. Okay, 1. Right? This is 1. Okay. So 1 point. Now y is equal to f of x. Okay. So e raised to 0. E raised to 0 is 1. Then find out e raised to 0.1. Okay. F of 0.1. So that means e raised to 0.1. So e raised to 0.1 is 1.1052. Similarly, you can find e raised to 0.2, e raised to 0.3. You have to find all these values using your calculator. Okay. So find out all these values, right? Okay. Find out all these values. So y0, you will get y0, y1, y2, y3 up to y10. And when we use trapezoidal rule, so we know that integration 0 to 1 e raised to x dx, that is equal to h by 2. Okay, what is your formula? Don't forget the formula. This is your formula, h by 2, y0 plus yn plus 2 into all other values. So h is what? 0.1 by 2, y0 plus yn. Y0 is the first value and yn, that means the last value. So 1 plus 1 plus last value is 2.7183 and plus 2 into all other values. Okay, so 2 into 1.1052 plus 1.2214 plus 1.3499, okay, plus 1.4918 plus 1.8221 plus 2.0138 plus 2.2255 and plus 2.4596. Okay, all this value you can easily calculate using your calci. So here you can see that whatever I written, you can see this step. Okay, and the final answer is 1.7196. So using your calculator you can easily find out this value. And in today's session we understand what is trapezoidal rule. We already solved 2 examples. Try to solve more and more example for your confidence. Okay, so thank you.